everybody on Zoom and in the room. Thanks very much for inviting me today, Colette. And as I say, I've been anticipating this workshop for the last 3 years, so it's really nice to be here. Thanks. I want to talk to you about peer assessment and my personal experiences. I'm a lecturer in the School of Computing Science, and we've done a few different peer assessment exercises in a range of different settings. I'd like to talk to you about that for the next few minutes. Or the alternative title is How to Make Students Work Harder and How to Let Us Be a Little Bit More Lazy, perhaps. But there are good motivations for this. I didn't get the memo about using Slido, so I'm afraid I'm on Mentimeter. Sorry, everybody. But if you wanted to pop up an extra tab in your browser, you could go to menti.com. And with this number here, you should be able to get to my Mentimeter questions. Please do, if you've got a laptop open, and Zoomers, please do that as well. I've got the Mentimeter results here, so I'll be able to see what's happening. Good. Right, I'll tell you when to answer the questions. So we'll just carry on with that slide presentation for the moment. So, oh, sorry, I beg your pardon. Yes, certainly. 38, 87, 0, 61. I'll pop up the code again when it's time to answer questions. But if you're very keen, you can be there already. Thanks very much. Good. So I want to think about the context in which we are all working, certainly those of us here at the University of Glasgow and probably other people as well. And this context is going to provide some motivation for why we might want to consider introducing more peer-based assessment into our lectures. So the first context is larger class sizes. I teach a fourth year, final year undergraduate class in functional programming. Is last year's Moodle page, and there are 150 odd students in that class. So this is an elective module. This is quite a big honours class here, and it's probably doubled in size in the time that I've been at Glasgow. So, you know, the students are somehow being compressed into our classes, and we are having to teach more and more students. Or maybe we're in the blended online learning world, and we are teaching students on Future Learn, with which the University of Glasgow has a partnership. So this is roughly the same course as an online course, and here there are, ouch, 21,945 students. Well, Future Learn cheat a bit to sort of massage the statistics. That's over several iterations of the course. So really the course has run 10 times, twice a year for the last 5 years. So maybe there's 2,000 students on each run, but that's still an order of magnitude more than the number of students I'd have in a face-to-face traditional Glaswegian class. So that's a lot of students to teach. So that's the first context. We have larger classes, which could make for a lot more marking. Oh dear. The second context is lower engagement on the part of the students. And I think this is something that the Times Higher Education covered fairly recently. Look at this. Class attendance plummets post-COVID. And maybe if you've done any face-to-face teaching in the last 6 to 12 months, you will have noticed that as well. You know, people aren't turning up. They're like staying on Zoom in their pajamas with their cameras off. Maybe you're not in your pajamas, but you know what I mean. And there's a definite sort of sense of, kind of student disenfranchisement and possibly less engagement with classes. Okay. So that's the second contextual problem. And the third one, I think, which is, university higher management. I don't know any higher ups here today, doesn't look like it, does it? But, they're always on the drive for increased efficiency so they can do more with less and increase the university surplus to build more shiny new buildings and whatever else they do with their surpluses. Okay, so we want to be efficient, or at least the university wants us to be efficient. So I think these are three contextual forces that are going to lead us towards more peer assessment, perhaps. And what I want to do is to go through some different models of peer assessment, different deployments of peer assessment, and just ask whether they might address any of these problems. So it's time for you to reach out for your Mentimeter and answer the first question. So what makes an exercise, whether it's a piece of coursework or some kind of class test or whatever, what makes something appropriate for peer assessment. You can copy the person sitting next to you, that's fine. We believe in peer learning, or you can do it on your own if you'd rather. And if you haven't got a laptop, then just peer over someone else's shoulder and type something in, please. We'll have a minute just for people to type in things here. What makes a peer assessment, an exercise appropriate for peer assessment? Oh, we get lots of answers here. Now, if I were Clever Collect, would I be able to go to the browser screen and see that as well? Sure. I wonder if I would, maybe, but I've got it on there, so I need to log in on that one.
I think it would just be easier.
Yeah, okay, so if I go to a web page and go to mentimeter.com and sign into me.
What's you do know more than me?
I'm going to go here, maybe. This might work. This is giving you lots of time to answer the questions. This is ideal. Thank you. Log in. Oh dear, this is never going to work, isn't it? Okay. Oh, SSA, maybe. What's that organisation's name? It's Glasgow University. Is it? You're probably right. I think you're right. University of Glasgow. Yay! Well done, that's good. How exciting. I think this is going to work. Oh dear, that's me. Right, I need to log out of that one perhaps. Bing. Right. Results. No, keep the results. Oh, it's gone. Come back, come back. There we go. Right. So it's quite hard to see. Isn't it? I wonder if we can zoom in, perhaps. No, maybe not. Oh, well, okay. I shall read out some solution to you. So, what? Oh, help. Wow. It did zoom in, didn't it? Yes. Okay. Yes, there's lots of possible answers here. Yes, easy to judge answers, large classes, yes. Something fun, oh, that's nice. Qualitative grading, yes. Level of complexity, yes, presumably not too much. Doable, yes. A common task, yeah, okay. Yeah, flexibility, criteria known in advance, yes, I think that's important. Yes, low stakes if graded, quite possibly, yes, good. Ooh, there's lots of answers here, good. Lots of people in the waiting room apparently, good, yes, okay. Easy. Yeah, okay, that's fine. Thank you very much. They're all very interesting answers, and we shall carry on with our quiz. F5 or Shift F5? I don't use a map. I don't use a Windows one. Shift F5, good, okay, excellent. Right, okay, so thank you very much for your answers. Here is Topping's canonical definition of peer assessment. Peer assessment is an arrangement for learners to consider and specify the level, value, or quality of a product or performance of other equal status learners. The idea is that you're looking at your fellow learners and their work in some sense, which possibly you've been doing as well, and to try and somehow provide some feedback, whether qualitative or quantitative, on the quality of that work. Okay. And we do peer assessment, and we have facilities for doing peer assessment here in the university. This is a survey from some work which Vicky Dale and I did on our functional programming course to see where learners get their information from, where they kind of value, what kind of support they value. So they value lecturers, isn't that nice? They also value teaching assistants. That was some kind of online tool we used. Okay, and they value their peers. Okay, so a fair proportion of them, nearly half, value their peers and think their peers have provided support for them. So that's encouraging. You know, people do recognise that their peers can be helpful in a learning context. Here's one of the comments from that particular focus group. One learner said, when I got stuck in my exercises, I looked through the comments. So this is in the assessment page, learners could say things to each other. And it turned out other people had similar problems. And of course, this is what software developers do all the time. So if you do write software, as some of you here have already admitted to doing, you always go to Stack Overflow. Hands up if you've been on the Stack Overflow website. Yes, fantastic. And you find somebody else who's got exactly the same error message as you. And mercifully, they solved it. Well, they didn't. Somebody very helpful came along and solved it for them. And you just copy and paste the solution straight into your source code and it all works fine. So this is a common model of peer learning, perhaps. Of course, one needs more engagement than just copying and pasting. And we'll come on to that a bit later. So what I want to do, that clock definitely doesn't work, does it? No, never mind. Okay. Will you shout out when it's time to stop? Oh, that's great. Okay, good. What I want to do is run through 2 example deployments of peer assessment now and explain to you how they've been working. And the first one of these is an approach called ACJ, for which Neil, say hello, Neil, is really responsible. He developed it and I've just been using it in my functional programming classes in computing science. So this is assessment by pairwise ranking, and this comes from college, from a 2012 paper, Adaptive Comparative Judgment, ACJ. And the idea is that you would sort of compare 2 assessment submissions side by side and say, I prefer this one, or I prefer this one. And then you're given another 2 pieces of assessment and you compare those. So you're always making a judgment between 2 pieces of work rather than all the pieces of work in your submission portfolio. Okay, and you're just saying which one of the 2 things is better. And eventually, of course, this becomes a sorting algorithm, which is very nice, slightly fuzzy sorting algorithm, but it allows you to somehow rank all your pieces of assessment. And this can be done over several rounds. So this is a set of benefits for this comparative judgment approach, which was drawn up by Steve Draper, who's not here today. I thought he might be, but he isn't. But there's lots more information about this on Steve's voluminous website. So this is a very scalable method because at any one time, you're just looking at 2 pieces of work, and then you can do that as few or as many times as you like. You can do this with sets of markers rather than just a single marker, provided presumably that they have a similar sort of grading mindset and criteria. It's very easy to use for peer review, as we'll see, and you can use it to mark diverse forms of assessments, and also to mark between different forms of assessments. And you can easily have a set of example pre-marked solutions that could be used for some kind of calibration, perhaps. So we've got software to do this, thanks to Neil, and this has been used in various contexts at the university. 1 year, I think, for the Learning and Teaching Conference.
I think they used it twice for them.
Twice for the Learning and Teaching. So when you submitted abstracts to the Learning and Teaching Conference, some poor person sat there and said, I like that one better, I like that one better, I like that one, and did lots and lots of ranking, and then they peeled off the top N from the final ranking. I always seem to get my abstracts rejected, so I don't know what I'm doing wrong, Neil, but never mind. Yes, and this has been empirically validated, where, a set of assessments has been marked twice, once using the ACJ method and once with expert markers, and supporting the claims that we saw on the previous slide. And when it was used, it provided better results and faster results. So this is to do with the scalability and the kind of efficiency drivers here. So the tool that Neil's developed can be embedded in any learning environment. It has been embedded in Moodle. I don't know if it's in the latest version of Moodle, latest build. I don't think it is, but it has been. No. It has been in the past and could easily be in the future. It's also available in MOOC platforms like FutureLearn. Hands up anyone who's running a FutureLearn course at the moment through the university? No, okay, never mind. Well, there are FutureLearn courses running, sponsored by the university, and any other LTI compatible VLE. it'll accept a range of different submission file types. So you can have text files and PDFs and JPEGs and videos and all sorts. And then submissions could be added directly by the students, or staff could submit them all in a kind of bulk upload exercise. And there's phase for submission and for review, and you can enable teachers to be reviewers or students to be reviewers. So we're going to see a kind of illustration of how the exercise works. So it's done in rounds. To start with, everything's sort of randomly sorted. So, you know, all the submissions are just kind of placed in a kind of haphazard way. And then we start to compare pairs of submissions and use that to somehow sift the thing into a more sorted process. So look at this graph here. Right. So the exercise, sorry, the submission we are interested in is the yellow one. There's the yellow one there. You see, submission number 43, and the true sort of quality of the submission is indicated by the shade of grey. So I think we're saying here that the lighter shade of grey is a better submission, and a darker shade of grey, whoops a daisy, is a lower quality submission. And you see these red dots here. So what happens is, here's the initial unsorted set of submissions. And then in each round, the rounds are going down vertically, okay? In each round, we compare our submission against one other submission. So you can see here in this first round, we've compared the yellow one against this red one here, okay? And based on the result of that comparison, then our yellow one will move either up or down, depending whether it's a higher or lower quality than the red one. Okay, and what we see is that the yellow one over successive rounds of comparisons is moving that way, which means hopefully people think this is a good piece of work, and these ones that are going down there, those are bad pieces of work, or worse than things that we compared against. And as time goes on, rather than comparing against random other submissions, you compare against things that are close to your submission. So you're trying to do a sort of more fine-grained comparison now in an area of a relatively similar quality submissions. And as the thing goes on, the rounds are continuing vertically down here. We see we almost have a beautifully sorted set. Look at the colour scale there. And this is a simulation. Did you have some randomness or some kind of...
I think everything's given a random number for its real value between 0 and 100, and then there's a random between 5 and 0 and 5.
So this allows for some kind of inconsistency in learner judgments, but even despite that, we see the thing is compared against multiple other submissions. How many rounds are there here? There are 15 or so, and things are ending up in roughly the right place. Good. Okay, so there's the algorithm, and there's the implementation, and there's lots of notes from Steve Draper about this. Okay, so please can you go back to your Mentimeter page, and we are going to do some actual comparisons. Now, this may or may not work well, because I'm going to show you some source code. But lots of you said you use Stack Overflow, so you're all used to looking at random source code. And this source code is actually functional programming code. Okay, so this is Haskell code. So pretend I've asked the learners to write some code to implement the Fibonacci function. Okay, so there's multiple ways to do this, and the learners have provided different solutions, and we're going to try and grade those. Now, there's two ways to do this. We can either have a sort of implicit sense of quality, where we just say to the learners, which of the two, when they're doing a pairwise comparison, do you think is better? Or we as educators can say, here's some criteria for what better means. Okay. So I'm going to tell you, of course, this might not work if you don't really know what Haskell looks like. Maybe you don't, but never mind. I'm going to tell you that better generally means concise code. So it's kind of quite short. Better certainly means the code gives you the right answers. And better normally means that the code, when you run it, is kind of more efficient. It doesn't use too much memory or doesn't take too long to compute. Okay, so here is the first two. No, this is where it's not going to work, so I'm going to go down here and go back to here and move on to the next thing. Do that. Yes, good. Okay, great. So here is the first pair of submissions here. So here's some code, right? And oh dear, what are we seeing here? Two solutions to the Fibonacci function. So this is a bit of a dodgy one, which is kind of using some kind of, what's this called? Any mathematicians know? I think this is some kind of identity function or something that allows you to kind of compute Fibonacci computationally rather than in the kind of recursive way. And here's some kind of funny code here that's doing something with addition over a list, and that looks quite complicated as well, doesn't it? So which of these do you prefer? And if you don't know, that's fine, just randomly select one of them. That's okay. That's all the peers are going to do anyway, isn't it? Now, they of course will have had much more insight into this process, because before they will have looked at these, they will have had to write their own. So they will have struggled with this already, and they will have thought, oh, how am I going to implement the Fibonacci function? And if they didn't go to Stack Overflow, or even if they did, they would have found one of a variety of solutions or implemented one of variety of solutions, and perhaps they recognize one of these two, or perhaps they don't, or perhaps they say, and this is such a common thing to say, aha, I wish I'd thought that was a good way of doing it, because it really is. So they get insight from this assessment, even though this wasn't the way they actually implemented it themselves. So let's see if anyone's voted. Please vote now. Okay, oh, how exciting, good. So you can't see left and right anymore, which is a bit annoying, but never mind. I wonder if I could make this really, really small and still show you the PowerPoint. Will that work? Okay, that's nice, isn't it? Great. Okay, good. So right seems to be winning. Good. Yes, and I think I would probably vote it right as well, definitely. Okay, good. So those are two programs, and that's the first pair of comparisons we're going to do. But there are other programs that other people have submitted, so let me go and see if we can find some more programs. So here's two more programs that people have submitted. Oh, this learner got a bit stuck. Sorry, I don't know, but they submitted it. That's okay. Sorry, I don't know. So I don't think we're going to give that one a very high ranking, because it's only correct for the first two values. And here's one here. Oh, look at that elegant mathematical definition. That's nice, isn't it? Effectively, they've transliterated the mathematical definition of fib. It's going to be very, oh, sorry, I shouldn't move around, should I? It's going to be very inefficient, but you know, it's correct. Good. Oh, and this is nice as well. So they put a type signature. Fibonacci takes an integer input and gives an integer output. They didn't do that, did they? Okay, good. So hopefully you've all voted this one. This one should be a resounding. Oh, sorry, I forgot. I need to advance my voting thing on one. Right, so try again. Try again. Which program is better? Yes, and of course I'm influencing the results here by showing you what's there. Oh wow, very quickly, everyone's decided left is better. So this is unanimous. Well done, thank you everybody, that's good. Okay, so there were only 4 submissions for this exercise, which isn't really enough to do a very good ACJ comparison, but I didn't want to go on for hours. So let's now go and compare pairwise the comparisons we haven't done yet. So we'll move down one slide. Can I do that? Okay, good. So here we go now. We've got this one here, which is cheating with our, golden ratios or whatever it is, and this one here, which is doing the kind of mathematically recursive definition. And hopefully you should be able to vote again. Okay, and oh, don't look, just vote. Okay, and you'll be able to vote this time. And really, I think what we're doing now is we're going to try and find out which one's going to go right to the top. And hopefully, there we go, right is better. There we go, you put that one up at the top. So this one, if you remember that graph before, is now going to float all the way over here. This is a really good submission. And this one's going to languish somewhere in the middle. Okay, good, well done everyone, thank you. And then we'll do the last pair of comparisons, which is this one here. Okay, so here was our complicated data structure using lists, and it's actually very efficient, quite elegant, a bit complicated. And then this one here is broken. So we vote again. And oh, I need to move on, don't I? Or do I? No, I don't think I do. That's the last slide, isn't it? Yes, good, okay. And there we go. Yes, so we said there was some inaccuracy, didn't we, in the other rankings, or maybe that was left over from the previous one. Okay, good. So we're doing this by hand at the moment. We're performing this process, but actually this should all be mediated through a computer. So we would have real learners opening up a web page and looking at these different solutions here. And help, if I get back to that. Not like that. Help. Okay. Looking at these different solutions and working out which one of the two is better, and then clicking left is better or right is better. And as they do that, we're building up a set of data points that allow us to do this sorting algorithm. And eventually, after a certain number of rounds, we have a nicely sorted set of exercises. Okay, great. So how did we actually deploy this in practice? Well, in our Future Learn course with our 1,000 or 2,000 learners in a single run, other tip of the day, for online courses, you need groovy logos and weird taglines. This is supercharge your coding. And everybody immediately said, oh, I must sign up for that course. So yeah, you need a groovy logo and a nice tagline, then you're aware. Good. Yeah, so 1,000 people did this adaptive comparative judgment. They worked on a slightly different problem. And then once they'd done the problem, we asked them to assess other people's solutions after they've submitted their own solution. So this is the information they received, the problem specification, okay, which is what they were going to implement. So I said to you, do the Fibonacci function, but I said to them, do something else, as we'll see in a minute. Some kind of judgment criteria, so guidelines about quality, a bit like I said to you, and it's slightly more evolved. Sometimes you can leave those as sort of emergent criteria and let the students decide for themselves what the criteria ought to be, and that becomes a learning outcome. Then the students are finding out what a good quality submission looks like. Then they compare a range of other people's submissions, and it becomes a bit addictive. You kind of log onto the system and you start off comparing one pair of solutions. Say, oh, that was good. Then you do another one. Then you do another one. You keep on going. And some people do hundreds in a night. And, you know, it's just click, click, click. I hope they were doing more than just click, click. I hope they're looking at it carefully and thinking about it. We should probably have implemented sort of a timeout or something, Neil, after a while. But yes, they were clicking away, and some of them did hundreds of comparisons. And as you do the comparisons, you see the ranking changes over time. And then at the end, when we'd finished, we told them roughly where they were in the full set of comparisons. We gave them a quartile, being you're in the top quartile, bottom quartile, or the second or the third. And then we also provided them with a sample solution, which was my solution, which sadly I put my solution in, didn't actually come top, which I was a bit disappointed about, but never mind. It was a good solution. Yeah, so this is actually what they had to do. So here's their instructions for their code they have to write, and some kind of sample use cases there. And then I gave them very clear explanations of what I thought a high quality piece of code should look like, which then becomes the assessment criteria when they're doing the peer assessment. Okay, there's my sample solution. I have comments in my sample solution, and lots of type signatures and lots of recursive functions. So this is what some of the students said about the system. I like this. I can see different ways of thinking. Try to understand which one is better. Hope to make my own code more efficient. It forces you to think differently. Compare your work against other people's work. See how well you're compared to your cohort. Useful exercise, organised in a great way. I would like to thank the course education and maths. As you start comparing, you see different approaches. Students use everything to be compared faster. So that's nice. Right, really quickly, because we're running out of time, the second case study is still work in progress. We're now building a Coursera online course called Computational Thinking in JavaScript. We haven't quite got a groovy logo here. Here's a pixelated brain with some JavaScript inside it, but we'll work on that. I think the brain should be pink, but they said yellow. I don't know. Anyway, yellow brain it is. And this idea, the idea behind this course is we want to give people who've never done programming before some basic experience in development of JavaScript code. And eventually they're going to deploy their own app, hopefully. So the peer review model in Coursera is that you read some background material, watch some background videos, then you are instructed to do some work for yourself. When you've submitted your work, you then read the assessment rubric for other people's work, and then you inspect work from maybe 3 other people and provide feedback. And then when the whole thing's finished, you receive your personal feedback. Okay, so similar, but rather than comparisons here, instead you're looking at each piece of work in isolation and just using the rubric to provide assessment about it. The rubric normally is kind of yes, no answers. Did the students, I don't know, provide documentation with their code? Yes. Is the code well formatted? Yes. Can you compile it? Yes, and so on. And then eventually you get some kind of coarse-grained mark. And they can also provide textual freeform comments as well. This is what it looks like on Coursera. Yeah, so you get the instructions for your own task, then you make your submission, and then you get assigned some peers. Apparently, one of the problems in Coursera is because this is quite an involved thing, sometimes people sort of give up and don't bother reviewing everybody else's work, so your work kind of stays there and nobody ever looks at it, which is a bit sad, but there are kind of ways around that. And then you can discuss afterwards, which is really nice, and you can talk about your learning experiences and your response to the feedback that you received. And these discussions, I think, are where lots of the interesting interaction takes place. Will it work? Well, we don't know, because sadly, this Coursera course is still under development and it should be finished by the end of June, which is next week. We haven't quite finished it yet. So I'll have to come back and tell you whether it works. We're using this for two major steps in the Coursera course. One is for requirement specification, where they're thinking about what is a good idea for an app I want to develop. Okay, and another one, they've built it for, does the app they've built actually work? Okay, so I'm going to conclude and then we'll have some Q&A, hopefully. So are we able to scale to larger classes with peer assessment? And I think the answer is yes. So the learners are here doing the assessment. This is, as some of you noted, low stakes assessment. So on our functional programming course, the peer review work counts for 5% of your overall score. And in fact, when we did this on Moodle for our local learners, you got your 5% of the coursework mark just for participating. It wasn't based at all on whereabouts you end up in the ranking. So really, it was more of a kind of formative thing, I suppose. But it works with classes of up to 1,000, as we've seen. Is it able to engage students deeply? Well, it engages some students. So some people really do get involved and do this. Others, as you saw there, submit a very poor assessment and just kind of randomly click through. And I think it's interesting to see how we can increase that student engagement. So I think making students aware of the subtleties of assessment is a good thing by getting to do it themselves. But actually forcing that, whether it's by attaching credit to the work or really embedding it deeply into the course, is perhaps challenging. Is it more efficient for teachers? Right, so it's more difficult to set up. These things always are. But once it's set up, we just sort of lie back and let the students do all the work. And that's very nice, isn't it? So there we go. That's the end of my talk. Thank you.
Thank you.
Hello, Scott.
Hello, thanks very much. I was interested by the final step of it all. So as far as I see it, never having used it myself, the system is all about showing students the diversity of possible solutions.
Yes.
And so your choice at the very end to show them an example, I wonder if there was any thought behind that, if you've just specifically chosen not to show them the top 5 that came out of it. So
that's very interesting. Yeah, okay. So what you're saying is, because we've got this sort of broad diversity of solutions, then perhaps if we showed them a range of good solutions, then they would realise that there's multiple ways to solve the problem. So I was hoping that they would have picked that up through the review process, and lots of them said they did, but maybe we could reinforce that by providing good examples at the end. Yeah, okay, thanks. That's nice.
I wasn't sure how many of them they would get to see based on how many they have to review before this thing is finished.
Okay, so in our in the Moodle context where we deployed this, I said to the students, you must do at least 5 judgments in order to get full marks for this, and full marks was 5%. To get full marks for this exercise, 5% of the overall weight of the coursework for the course. So they all did at least 5, but many of them did, 50 or 100. Yes. So I didn't actually put up the data for that, but yeah, you'd see there was, they're all doing a sort of minimum number of comparisons. Yeah. I suppose the question is, would that 5 be enough to see the diversity in the solution space? Yeah, I'm not sure.
So someone's asked who Neil is. Can you just briefly introduce the person in the corner?
Neil, do we sort of point the camera over there? So Neil Barr is a learning technologist. Are you currently attached to science and engineering, Neil? Yeah, okay. So if anybody's interested in deploying ACJ in their own courses, I think Neil will be very keen to help support that, and I'd certainly be able to give advice as well. As I say, it was in a previous iteration of Moodle last year, certainly, and we could possibly get it in for this next year as well.
Yeah, I've got to do a re-upgrade before it goes into the next issue of Moodle, because they updated the way it's meant to connect, and I need to make sure it's on a reliable server in science and engineering. It is feasible to get it working at the moment, and it's been used by physics this year, but it's not official.
Okay.
Yeah. There was a question asking about whether students are doing too many comparisons with them. Oh, biasing it. Yes, that's something that's a current issue in the software, that a student can just get too enthusiastic and do too much. So I'm going to limit that in the next release of the software.
A question here.
Yeah, thanks for a really interesting talk. A bit of a technical question. How many comparisons do you need to sort of reliably get rid of the random ordering at the beginning? And how does that grow as the class size grows?
Yeah.
We're just wondering whether this is efficient if you get very big classes.
One of the big English exam authorities did an experiment with this a few years ago at Excel. But they were looking at thousands, and they found much the same as I found in my simulations, that after about 12 to 15 rounds of comparison, it doesn't really matter how many start, the ordering is really good.
So in a round, everything is compared with one other thing.
Yes.
Okay.
The round is one set, and everything gets compared with one other, which at the beginning is completely random, and then the algorithm changes slightly as it goes down, because it's sort of the comparisons are closer. So it scales away efficiently. Yeah.
Yeah, and I think given that we aren't using it to actually provide real marks, I think the learning value is useful, even if the final ranking isn't as good as you might want it to be. But we generally do get to, how many rounds do we get to in our houses? We need to look at the stats, but I think we certainly get past 10. Yeah. The way we run it is normally we'd have a 2-stage process where you get 1 week to write your own solution and then 1 week to rank other people's solutions. So it's sort of tightly bounded in terms of time.
Will we answer some of the comments on Slido? So do students' judgments become less definitive when they're asked to compare very similar answers?
Yeah, okay. So this is a good point. As you get to that later stage, you're looking at solutions that are perhaps very similar to each other and similar in quality, perhaps. The solutions won't move very much then because they're sort of in roughly the right place. Perhaps the learning value diminishes as you get closer to the final sort of solution. Yeah. Do you want to comment on that, Neil?
I think it would be great if students all went in right at the beginning and kept going right to the end. extent it would be getting progressively harder to make judgments and have to be thinking a bit harder. Obviously, at the very beginning, randomly, they can end up with two very similar. But unfortunately, we don't get that. We tend to go in for a period and then out. So we get much the same level.
Yeah.
And I guess another comment here asks if, oh, where did it go? Yeah, can it be demotivating for students who struggle with their work? And there's also a comment in the Zoom chat saying that they think it might work well for students who are kind of middle to upper range in achievement, but for weaker students, they might not benefit from it at all. So there seems to be a few different.
So, okay, the demotivating point is interesting. Thanks for that, Colette. Yeah, I think the way we set it up is that it's participation that gets you the credit rather than any actual correctness in your code. So as long as you submit something, even if it was that, you know, I didn't know what to do here, you're still going to get the credit. And once you start looking at other people's code, which is a very important skill to have really, and to be able to develop, I think you would see other solutions. And I hope that wouldn't be demotivating. I hope that would be perhaps instructive and inspirational, perhaps, to see other people's solutions. And it might be that you actually see other people who struggled as well. So in that sense, you realize that you're not on your own. Yeah, do you want to say anything about that, Neil?
It's not something we've really looked into. I expect we looked at Steve's website and found he'll have got a literature review.
Quite possible. Yeah. Yeah. Okay.
Yeah.
Okay.
So I think that's more or less time up for this session. So there are comments here both in the Zoom chat and also on Slido. So please, if anyone does have any more comments or questions, or Jeremy, please post them on the Slido, either as a question or on the live poll, and we will try our best to address them at some point, either later today or we'll pass them on to Jeremy tomorrow to provide answers to.
Thank you.
So yeah, thank you everyone. So we're going to go into the morning break. So we will come back at 11:15 for those who are on Zoom. For those that are here, we've got things outside